Okay. So, to start with, you have a set of vectors psi 1, psi 2, etc. up to psi n. Okay. And given that these are linearly independent, and of course they do span the space, but they are not orthonormal. So, I need to construct an orthonormal basis out of this, say phi 1, phi 2 up to phi n, and this is what I need to do. Okay. So, what I do is, like, I will take the first. So, I mean, you can just think like this. Suppose you have two vectors, I mean usual sense, you have two vectors, say a1 and a2. Okay. And clearly, I mean, these are not orthogonal, and so what I do is, first to make this vectors orthonormal, what I am going to do is, I am going to first I am going to normalize this vector a, and then I divide it by its norm. Okay. And then I call it as a1, say tilde. This is my small a1, I can call this small a1 is capital A1 divided by the modulus of A1, and that is my. So, what I did is, I normalized the first vector A1, and I call this vector as A1. And then what I do, in order to now I take the second vector to make the vector A2. What I am going to do is, I am going to take the vector A2 and I will subtract out the component of A2 in the direction component of A2 in the direction of A1. Then you will get a vector which is perpendicular to A1. Okay. So, what I need to do is, I need to subtract out the component which is in the direction of A2 or in the direction of A1. Okay. So, what I do is, I will take the first, I will make first phi 1 from this set by taking psi 1 and then dividing it by its norm. The norm is psi 1 all raised to half. This is the first vector. Okay. And to get the second vector, what I am going to do is, I am going to subtract out the component of psi 2 along phi 1, and then I will normalize the vector. Okay. So, I will take my phi 2, I will just denote it by phi 2 first. This is not normalized, just so phi 2 tilde, that is equal to psi 2 minus phi 1 psi 2 phi 1. So, what I did here, I took the vector psi 2 and subtract out the component of psi 2 in the direction of phi 1. So, that is what I did, and now I will normalize this divided. Okay. So, this is so my phi 2, actual phi 2 is equal to phi 2 tilde divided by its norm, phi 2 tilde all raised to half. Okay. So, I need to find the norm of phi 2 tilde. So, the norm of phi 2 tilde is phi 2 tilde all raised to half. Okay. So, I will just first evaluate phi 2 tilde. So, that is equal to psi 2 minus phi 1 psi 2, if I need to take the dual corresponding to this one. So, it will be phi 1 psi 2 star into bra phi 1, and then you have to take the inner product of that with itself. So, you will get psi 2 minus phi 1 psi 2 phi 1. So, if you take the inner product, you will get, first one is psi 2 minus phi 1 psi 2 and then psi 2 phi 1 minus phi 1 psi 2 star. So, phi 1 psi 2 star into phi 1 psi 2 plus phi 1 psi 2 star into phi 1 psi 2, and then we have a phi 1 phi 1. But you know that this phi 1 phi 1, phi 1 is already a normalized vector, so phi 1 phi 1 is actually 1. Okay. And if you look at this, this is equal to psi 2 psi 2, then phi 1 psi 2, then you have a psi 2 phi 1, that is nothing but phi 1 psi 2 star. Okay. So you can say that this is mod square. Okay. Phi 1 psi 2. So what I am saying is, this is actually the star of this. Okay, this one, the psi 2 phi 1 is phi 1 psi 2 star. Okay, so together you can write it as phi 1 psi 2 mod square minus, again this is the same thing, phi 1 psi 2 mod square, and then this is plus phi 1 psi 2 mod square. Okay, so one of this will cancel away, and then you will get phi 2 tilde is actually equal to psi 2 minus phi 1 psi 2 mod square. Okay. So now I can write my vector phi 2, I mean I'll write in this corner. Already my phi 1, I wrote it as my vector psi 1 divided by psi 1 all raised to half. So now we have the normalized vector phi 1, which is psi 1 divided by psi 1 all raised to half, and phi 2 is actually psi 2 minus phi 1 psi 2 phi 1 divided by psi 2 minus phi 1 psi 2 mod square all raised to half. And you can similarly you can show that phi 3 is going to be equal to psi 3 minus, you need to subtract out the component of psi 3 in the direction of phi 1, and then you need to subtract out the component of psi 3 in the direction of phi 2, and then divided by its norm, and that is going to be equal to psi 3, you can check yourself, psi 3 minus phi 1 psi 3 mod square minus phi 2 psi 3 mod square all raised to half. Or you can in general write phi k as psi k minus summation I is equal to 1 to k minus 1 phi I psi k phi I divided by psi k minus summation I equal to 1 to k minus 1 phi I psi k mod square all raised to half. So I mean, so in this way you can construct orthonormal vectors phi 1 phi 2 phi 3 etc. up to from the vectors from the basis psi 1 psi 2 psi 3 etc. psi 1 psi 2 etc. And this procedure is basically known as the Schmidt orthonormalization procedure. I will do an example and then it will be clear to you. Okay. Alright, suppose that you have your vector phi 1, say psi 1 is equal to 1 1 1, okay, and psi 2 is actually 1 1 0, and say psi 3 which is 1 0 1. Okay, I mean you please check yourself that psi 1, psi 2, psi 3 are linearly independent. To see whether they are linearly independent, what you need to do is you make a matrix, okay, out of this. That means 1 1 1, 1 1 0 and 1 0 1, okay, and check the determinant of this matrix, and then if it is not equal to 0, you can clearly say that this, I mean, so if there you know that if this if these two rows have some sort of connection, I mean, like that means some sort of okay. So what I am saying is, if the vectors are linearly independent, then the determinant cannot be equal to 0, or if they are linearly dependent, then if they are dependent, then the determinant must be 0. So to check whether they are linearly independent, you can just form the matrix and find the determinant of that, then you will be able to say whether they are linearly independent or not. Okay. So of course they are linear, you can check that this determinant is not 0, so they are linearly independent. 1 0 1, okay. And now okay, so they are linearly independent, and of course they span the space also. I mean, so this is a basis, but this is not an orthonormal basis. So I am going to construct an orthonormal basis from this by Schmidt procedure. So what I am going to do is, I will take the first one, I will take the first, I will construct the first vector in the orthonormal basis by taking this vector and dividing it by its norm. So so what is the norm of this? So so psi 1 is going to be 1 square plus 1 square plus 3. So what I get is the norm will be equal to the norm of this vector psi 1 is equal to square root of 3. So I will divide it by square root of 3. So what I get is 1 by root 3 into 1 1 1, and this is the first vector phi 1. And then I need to construct phi 2. So phi 2, to get phi 2, so I will subtract out the component of psi 2 along psi 1, along phi 1, and then I will normalize that. So what I do first is, I will just look at phi 2 tilde. Phi 2 tilde is the vector psi 1 minus phi 1, sorry, psi 2 phi 1. Okay. So this is equal to, I mean, I can substitute from there. Psi 2 is 1 1 1 1 0 minus phi 1 psi 2. Phi 1 is 1 by root 3 1 1 1. So you will have a minus 1 by root 3, and this is bra phi 1. So it will be a raw vector 1 1 1. Okay. And then you have a psi 2. Psi 2 is 1 1 0. 1 1 0, and then into you have phi 1. Phi 1 is nothing but 1 by root 3, and that 1 by root 3 and this 1 by root 3 will make it as 1 by 3. 1 by 3 into 1 1 1. Okay. So let us do this here. So your phi 2 tilde which is equal to 1 1 0 minus, you have a 1 by 3, and if you take the product of these two you will get 1 into 1 plus 1 into 1 plus 1 into 0. So you will get 2 there. So 2 by 3 minus 2 by 3 into 1 1 1. So you will get this is equal to 1 minus 2 by 3, that is going to be 1 by 3, and again 1 by 3. Okay. Then you have minus 2 by 3. Okay. This is the vector, and if you take the norm of this and if you take the norm and divide it by it, you will get so this is your phi 2 tilde, or phi 2 is going to be equal to this divided by its norm. So I will immediately get it as 1 square plus 1 square plus 3 you can pull out, and this 1 square plus 1 square, so it will be 2 plus 4 6. So it will be 1 by root 6 into 1 1 minus 2. So, this will be phi 2. So, what I did is I took this vector and divided by norm. Okay. So, it will be 1 square plus 1 square plus this 2 minus 2, this square will be 4. So, 4 plus 2 6. So, what I just divided by that, and then this will be 1 minus 2. So, that will be phi 2. Okay. So, we have phi 1 and phi 2 now. So, here I will write this here. My phi 1 is 1 by root 3 1 1 1, and my phi 2 is 1 by root 6 1 1 minus 2. Okay. Now, I will go for my phi 3. Okay. So, phi 3, I told you you have to subtract out the components of psi 3 along phi 1 and phi 2. So, phi 1 psi 3 phi 1 minus phi 2 psi 3 phi 2. Okay. So, that is equal to your psi 3 is 101 minus phi 1. Phi 1 is 111 1 by root 3. So, 1 by root 3. So, you will have a 1 by root 3 into 111. Sorry, it will be a row vector. So, 111, and then your psi 3 is 101 into phi 1. So, that makes it as 1 by 3, and you will have a 111 here, and then minus. So, you will have your phi 2 will be 1 by root 6, 1 by root 6 into 1 minus 2, 1 minus 2 into psi 3. So, that will be 101 into 1 by root 6, that makes it as 1 by 6, 1 by 6 phi 2, that is 1 minus 2. Okay. So, I need to do it here. So, what I am going to do is work it out here. Okay. So, the first one is 101 minus. So, if I multiply these two, I will get again a 2 here, 1 into 1 plus 1 into 0 plus 1 into 1. So, 2 by 3. So, you will have minus 2 by 3 into minus 2 by 3 into 111, okay, minus, and then you have if I multiply these two, but I guess that will be 1 by 6, then I will have 1 into 1 plus 0 minus 2. So, minus 1. So, minus 1 by 6 into, so it will be plus 1 by 6 into 1 minus 2. Okay. So, that is equal to, so the first term it will be 1 minus 2 by 3 plus 1 by 6. Okay. So, and the second term will be 0, so it will be minus 2 by 3 plus 1 by 6, and the last term will be 1 minus 2 by 3 minus 1 by 3. Okay. So, this is equal to, so this vector, this is equal to, so this will be 4 by 3, 4 by 6, right. So, it will be 4 by 6. So, it will be, okay. So, let me see again, 1 minus 2 by 3, you will have a 2 by 3, that will be, oh, plus, okay, this minus, so it will be, you will give 1 minus 3 by 6, so it will be 1 minus half, so it will be a half here, and here it will be, you will have a 4 by 3, it will, so it will be again minus 1 by 2, and here you will have this will be 1 minus 2 by 3 minus, so it will be 3 by 3, 1 minus, it will be 0. Okay. Or this, so this is your actually oh, this is phi 3 tilde, this is phi 3 tilde. So, your phi 3 is going to be equal to, phi 3 is going to be equal to phi 3 is going to be equal to phi 3 tilde divided by phi 3 tilde whole raised to half. So, that is equal to, so you have to take this vector and divide it by its norm. So, you will get 1 by root 2 into, so 1 square plus 1 square, that will be 2, and square root of that it will be square root of 1 by, so 1 by square root of 2 into 1 minus 1 0. So, that is your phi 3. So, you have all this vectors. Okay. So, I will, here you have your phi 3. Phi 3 which is equal to 1 by root 2 into 1 minus 1 0. Okay. So, starting from this psi 1, psi 2, psi 3, we constructed 3 vectors, phi 1, phi 2, phi 3. They are supposed to be orthonormal. Well, let us check that whether they are orthonormal, and once they are orthonormal, we will just see whether the completion, we will look for, we will see, look at the completeness relation as well. Okay. Okay, so what is phi 1, phi 2? So, if you look at phi 1, phi 1, it will be equal to 1 by root 3, 1 by root 3, it will be 1 by 3, and then you have 1, 1, 1, and then 1, 1, 1. So, if you do this, what will you get? 3 by 3, this you will get 1. Okay. Similarly, if you do phi 2, phi 2, again you will get 1. If you do phi 3, phi 3, you will get 1. So, now let us look at phi 1, phi 2. Okay. If you get phi 1, phi 2, phi 1 is 1 by root 3, 1, 1, 1, and then phi 2 is 1 by root 6, 1 by root 6 into 1, 1 minus 2. So, so this will be equal to 1 by root 18 into 1 plus 1 minus 2. So, that will be 0. Okay. So, you will have your phi 1, phi 2 is 0. Similarly, you can say phi 1, phi 3 is also 0. Okay. And phi 2, phi 3 0. So, you can immediately get phi I, phi j, you will get delta I j. When I equal to j, you will get 1, or otherwise you will get 0. Now, let us look at the completeness relation. So, now let us look at, you have, I mean, by Schmidt procedure, we constructed 3 orthonormal vectors, namely phi 1, phi 2 and phi 3. So, now let us check whether the, I mean, your completeness, for your completeness relation. The completeness relation says that summation over I, phi I should be equal to the identity operator or the identity matrix. So, let us see whether that is true. So this is actually, I mean, you have I equal to 1 to 3, right. So, you have basically phi 1 plus phi 2 plus phi 3. So, what is phi 1? Phi 1, this is 1 by root 3. For this phi 1, there is a 1 by root 3. For this will be a row column vector, and this will be a row vector. So, you will have a 1 by 3 coming out, right, and then you have 1, 1, 1 into 1, 1, 1 plus, for phi 2 you will have a 1 by root 6. So, it will be a 1 by 6, and then you will have 1, 1 minus 2, 1, 1 minus 2 plus the last one you will have a 1 by 2, and then 1 minus 1 0, and you have 1 minus 1 0. So, now let us do this. So, this is equal to that. So, that is equal to 1 by 3 into, if I, so this, what will you get? This is a column vector into a row vector. Okay. So, you will get 1 1 1 1 1 1 1 1 1. So, 3 cross 3 matrix, 1 by 3 into this matrix plus 1 by 6 into 1 1 minus 2, 1 1 minus 2, and then you have minus 2 minus 2 4 plus 1 by 2 into 1 by 2 into you will have 1 minus 1 0 minus 1 1 0 and then you have 0 0 0. So, if you add these matrices, these 3 matrices, you will get so let us evaluate the first term. So, you will have first term, you will have a 1 by 3 plus 1 by 6, 1 by, so it will be 2 by 6 plus 1 by 6. So, that will be okay. So, it will be okay. So, 1 by 3 plus 1 by 6 1 by 6 plus 1 by 2. Okay. So, you will get 1 by 3, you can write it as 2 by 6. So, 2 by 6 plus 1 by 6, it will be 3 by 6, that will be 1 by 2, 1 by 2 plus 1 by 2, it will be 1. So, the first element, it will be 1. Okay. And let us look at the second element. Second element is actually 1 by 3, again 1 by 3 plus 1 by 6, that will be half. Then you will have a minus half, so that will be 0. And the third element will be 1 by 3, so it will be 2 by 6 minus 2 by 6, so that will be 0 and then 0, so that will be 0. And the third, this element will be 1 by 3 plus 1 by 6, that will be half, then you will have a minus half, so that will be 0. And this 1 by 3 plus 1 by 6, that will be 1 by 2 plus 1 by 2, that will be 1. And this element will be 1 by 3, so it will be 2 by 6 minus 2 by 6, that will be 0 and then 0. And similarly, this will be 2 by 6 minus 2 by 6, that will be 0 plus 0. And here you have a 2 by 6, 2 by 6 minus 2 by 6, that will be 0, then 0. And the last one is like 2 by 3, 2 by 6, 2 by 6 plus 4 by 6, that 2 by 6 plus 4 by 6, that will be 6 by 6, that will be 1, 6 by 6, that will be 1 plus 0, that will be 1. So, this is what you get. So, this is the identity element. So, you see, I mean, when you do Schmidt orthonormalization, I mean, you can see the complete relation automatically coming from here. All right. So, I think I will stop here and then continue in the next class.